Hello, and welcome to today's webinar by Qualisys. So today we are proud to introduce the QTM Scripting Interface. It's a new feature that we introduced with the QTM 2023.2 release, which is the latest release available. And the goal of today is that we are showing you how this feature works, how to work with the QTM scripting interface, and getting started with using and perhaps also creating your own scripts so that you can extend the possibilities of QTM to your own likings. So let me start by introducing the team. I'm Erwin Schoonderwaldt, presenting from the studio at Qualisys headquarters. I'm from the field applications and support team, and I'm mainly working on user documentation and software acceptance testing and a lot more things. Then we have on board also Henrik Norgren. He is a software developer in the software team, and he is the mastermind behind the Qualisys or the QTM scripting interface. So he will tell a bit more about it in a minute. And we have Jeff Thingvold from the field applications and support team as well. He is our animation specialist, and he will also tell a bit more about the resources we have available for the scripting. So shortly about today, we are first starting with an introduction to the QTM scripting interface by Henrik. Then I'm going to tell a bit about the resources we have on GitHub for the scripting. And after that, I'm presenting a section about getting started with scripting. Firstly, how to use scripts in QTM, and then also developing a simple example in which you see how easy it is to actually get started and make your own script. After that, we are going to talk more about more complicated examples or more useful examples, I must say, we have available on GitHub, which are the tools for post-processing, which Jeff will tell much more about. After that, we have time for questions and answers. During the whole webinar, you can always post your questions by pressing the Q&A button and posting your question there. The questions will be answered live during the session, and they will be published most of the time. And the session is going to be recorded and will be shared afterwards. So I wish you a pleasant ride here. Now let's go over to Henrik, who is going to tell us more about what the QTM scripting interface actually is. Hello, Henrik.
Hello. So first off, for those that don't already know, what exactly is scripting? I guess we can go to the next slide. Yeah, good. So what is scripting? Normally, the code for software, QTM in this case, would be written by us here at Qualisys, and it would be completely fixed, set in stone, so to speak. So if you wanted something to be changed or you needed a new feature, well, then you would first have to get us to do it, and then wait a couple of months for next release of QTM. With scripting, however, changes can be made by anyone, and you can see the changes immediately. So why do we want this? Well, the first reason, as I just mentioned, is if a feature is not yet available, you really do need them quickly, then scripting might be an option. The second reason is if you need something very specific, a feature, something that only makes sense for you and your use case, then scripting is a way for you to get that feature without impacting anyone else or bloating the software. The third is automation. If you have a repetitive workflow, for example, after each measurement, you click a certain number of buttons or you fill markers based on other markers, then you could automate that down to 1 or even 0 clicks. So that's scripting in general. I also want to talk about the design of the QTM scripting interface. When adding scripting to software, there are essentially two options. Either you run the scripts outside the software and communicate with the software using something like TCP, or you can embed the scripting language directly into the software. The latter is the approach that we're taking here with QTM. the scripting interface is designed to be language agnostic, meaning there's nothing in the API that is specific to, for example, Python. Rather, it's like a least common denominator using only types and features that are available in virtually any language. Currently, we support Python and Lua, and you can also call the interface via REST, even though that's not a scripting language per se. The advantage of that compared to the old REST API is that over time, this will cover more of QTM's features. And it's also nice to have the same exact interface everywhere, so you don't have to learn, two different ones or have two different sets of documentation and so on. Anyway, in theory, we could support other languages. Most likely, we would not stick to those three. It's even possible to run multiple languages at the same time, which normally you might not do, but if you start sharing scripts with other people and so on, that might become important. The scripting interface is also designed around the idea of callbacks, meaning that you have a function and then you tell QTM that when a certain event happens, you want this function to be called. So an event could, for example, be when the 3D world is being redrawn. When that happens, you could have a callback so that you do your own custom drawing in addition to what QTM normally draws. So you can see a minimal example there in the picture on the right that just draws some basic 2D text in the 3D world. So if you have some important information that you want to see displayed, then you can do so. Another event could, for example, be when a command is executed. Now, command here is a Windows term, but essentially all menu buttons in Windows are tied to commands under the hood, so that when you click those buttons, you execute the commands. The same commands can also be bound to keyboard shortcuts, or what Windows calls accelerators. Don't ask me why. So what you can do with the scripting interface is to add your own custom commands, as well as your own menus, buttons, and keyboard shortcuts. So you press your button, your function gets called, and then you can do whatever you want, gap filling, filtering. Jeff will show you some of that later on in the presentation. So those are the callbacks available today, but you could, of course, imagine other ones, such as adding your own steps to the processing pipelines and so on. I know people have asked about batch processing, and also during the morning session, people asked about real-time processing. So yeah, it's not possible right now, but it is a high priority for us, and most likely that will be the next step in the development of the scripting interface. So it's worth keeping in mind that this is just the first release. It's still very incomplete, but the plan, as I said, is to add more features over time until we've covered all of QTM. So that's all I had. Back to you, Erwin.
Yes, thank you very much, Henrik. I think that was a very nice introduction. So let me now go over and tell a bit more about the scripting, the resources we have for scripting. And I'm going to switch to my other screen here, where I've prepared a web browser. So the first and most important resource we have for QTM scripting is on our GitHub page. So if you go to the Qualisys GitHub page, you will find the QTM scripting project. And here, as you can see, this is the page here. We have a set of demo scripts that are included. We have a couple of helper functions that are used by these demo scripts, amongst others. And we have the tools folder, which contains a couple of real-world cases, like practical problems that we have solved with scripting as kind of an examples. And both these demo scripts, the demo scripts are showing a little bit more bells and whistles of all the different possibilities you have with working with menus, getting commands, adding commands, swapping out things in the 3D viewer, and all these kind of things. So that's gives some inspiration of what you can do with the scripting interface right now. And the tools can then be a starting point for doing some kind of mathematical operations, how to do things with gap filling, how to work with Sixtoff data, for example, or trajectories. So there's a lot of things already available which can show the examples of how to use it, and which you can use right away as well. We see here the startup script. So you have the startup demo scripts. That's one function that loads all the demo scripts, and we have the startup tools that loads all the tools, and you can use them both at the same time as well if you want. showing more about that later. Then we have the README information here, of course, which tells mostly about what it is and how you can use it. And another very important link is here, the link to the release documentation. So we have another tab here which actually shows that. And this is a very complete documentation about all the available modules that are available under the scripting interface. And for all these examples, for most of these modules, we have code snippets in the different available languages as well that show you how to use these commands. So this is also a very good resource for getting started with these modules. And if you go into one of these, for example, for trajectory, we see that we have all the functions, the table of contents here, where you see all the different things you can do within this part of the scripting interface. Another resource we have a QTM manual where we have recently added the appendix for developers' resources. And here we also have a chapter about the QTM scripting interface, which you see here. And this is a little bit more about how this works in QTM. And so that's the different resources we have there. Let's see. Then let's go over to the next part. Getting started with QTM scripting. So now I'm going to use to show more about how to use scripts in QTM. So we have QTM open here, and the two things that are available here are firstly, we have added a button here to open and show or hide the terminal. So here we have the embedded terminal. And here's another button that you can use to reload scripts that are loaded in your project. And the scripts that are loaded in your project, so you go to the project options here and go down to miscellaneous and scripting. There is the scripting page. And here we can have available the terminal settings where you can choose if you want to use Python or Lua as your scripting language, and you can set the text color to your liking. In this part, the script files, we can load the scripts we want to load on startup of QTM. So you see I've already added here the startup demo scripts and the startup tools scripts that are used to load these examples on GitHub. Let me now check this one for startup the demo scripts. And I press OK. And then we see that an additional menu is being added here to QTM. Let me see, I probably want to open a file first so that we have something to show there as well. So that's the example of a runner here we have. So here, yeah, you can just check. There's different ways you can, for example, switch to an advanced menu. So then you get some other commands here. Going back to the basic menu, we can show what kind of things you can draw in the 3D space. So when I do this, you see some big markers are added. We have another set of coordinate system axes being added, some arrows, and an upside down teapot for some reason. And here we can toggle that off again. So here, these examples, I really recommend to see what you all can do there. When I open the terminal again, we can, for example, list all the menus we have in QTM. So here, that's actually the existing menus. And this allows you, for example, to also modify existing menus. You can also add new shortcuts. So create a new menu that contains commands that are already available in QTM as well. So you can here list the custom commands. These are the ones that have been added by the script. That is open now, but we also have all commands in QTM available, and you can use these commands as well in your own script. So create your own custom menu, for example, with commands you are using a lot. So there's a lot of things already quite on the surface you can use to make things easier for you. Let's see. So the next thing, yeah, as I'm now going over to more showing how to write your own script. So let us start here with a hello world. That is usually where you get started with things. So I already set up a basic script for that, but let me first show a little bit how we can show things in the terminal. So I'm going to take away this demo script here again. So we have a clean terminal now and no extra things. So yeah, for printing hello world in the terminal, it's quite easy. You have the print command, which is a Python command, and you have, you say here, hello world. And we have to close the parentheses. So here, this is basically what we want to implement in the script now. So let's do it. So when you start a script, one thing that is important that you always import the QTM interface and possibly other libraries you're going to use. So that is done in the first section here. The first thing I want to do now is to add a new menu to QTM. So let's go and as in a good cooking show, I've already prepared the ingredients. So I'm taking this from my table here, pasting it in. So this is the command we use for inserting a new menu. So we call it a submenu. Since the ID we point to is none, it will appear in the menu bar, and we are going to call it my menu. So now I have to save this script, the change, and I'm going to load this into QTM. So I'm adding this script here. So here we are, we have the hello world steps, it's called. So I'm opening this one now here. And then we load it, and you see already that the my menu button has been showing up here. And it's currently empty because we haven't added anything to it yet. So let us go back again to the script here and develop that further. So the next step, as we see, we now have to add a new command to QTM. So first we have to create a function that creates hello world to the terminal, then add this as a command to QTM and associate that function with the command. And then we are going to add a menu button that will invoke this command. So that's basically the simple steps you need to follow in order to make your own custom command in QTM. So we start with creating the function that is going to do what we need to do. In this case, it's going to print hello world to our terminal. So a bit trivial, but that is just to show the proof of concept. Then we have the part here that is creating the command. So this is done in 2 steps here, but there's a helper function that can make that a 1-step process. Here I'm just going to show it as it is in the interface. So we have QTM GUI add command, and we call it echo hello. And then we are going to tell what the command is supposed to execute. So in this case, it's the echo hello command is going to execute the underscore echo hello function that is just defined previously here. And then the last thing we need to do is to add this as a menu button in the menu we just created earlier. And here we are going to use the insert menu button function that's available on the GUI, associated with the menu we have made. So use the same ID. We call it hello world, and it's going to execute the echo hello command in QTM. So going to save this and then show you again the use of the reload button. So we need to reload this script now. And now we see that actually the button has been added here, hello world. And if I'm clicking it, we see that hello world is appearing here in the terminal. So yeah, as we already said, there's different kinds of callbacks, and we can plot things in the QTM 3D viewer. So let us make it a little bit nicer now, and we are going to add a section that displays the hello world in the 3D viewer. So it's again the same setup. So we need to add a function that is doing that, and then add a callback, in this case to the QTM command that is making sure that the text is actually getting printed. So here we go. I've got the function already pre-cooked. So it's going here. I call it _display hello. It takes one input argument, measurement time, and that is because the callback actually has one argument that is the exact time of the drawing. So if you need to have something that is time sensitive, you can make sure that it's drawn in the correct location, for example, by having the measurement time as an input. So in this time, we are just going to ignore it, but it needs to be there. The function is based on the draw text 2D function, and we have to give it some coordinates. We have to show what to plot and then show where to plot it. And we can define the color as well. The other thing we now need to add is the actual callback. And I'm going to add it here to the echo hello function, so that it's this draw function is going to be first activated when we press the button. So it's associated with a QTM command echo hello. So there we go. This should in principle do the trick. Let me save the script again. I'm going to reload. And then this looks the same. So, but now if I press this one, we see hello world coming up here. And then we see also hello world being drawn whenever QTM is updating the draw. Now it's printing you the hello world here in the 3D viewer. Let me do one. Henrik already discussed one more callback type, and that is the keyboard shortcut. So what we call the accelerator, as it's according to Windows terminology. So that is the just one simple line of code is we set the accelerator. We specify what the Control, Alt, and Shift buttons are doing, if they're activated or not. And then we define which key to use. And we also associate it with the same command, the echo hello command. So now I'm going to save this script again, reload it. And if we now look at the command here, we actually see also that the keyboard shortcut is associated with this menu button. So you can be reminded about the keyboard shortcuts, as it is with the other parts in QTM here as well. And now I can also invoke this hello world function by just pressing Ctrl-Shift-H, which I'm doing now, and you see it works. So that's basically the things I wanted to show for the hello world functions. Now, this is a very basic way. So we just code this line by line, and we are having one line to set up the menu. So you can run the script once, and then everything gets done sequentially. But for the tools, we usually have a little bit of a different structure. So I'm going to show you how this would look like when we restructure it, as it would appear in our tools resources. And so what we add here is a menu priority variable, and this is just for the initialization function to recognize where to place the menu. So it needs to be specified, and it needs to be a number larger than 0 in order to place the menu. If you make it 0, then the menu will not be placed there. And here the other difference is that we have now one function that is called add menu, and here this is the place where we are setting up the QTM commands and the menu and the keyboard shortcuts and this kind of things. So it becomes functional, and the function is recognized by the startup tools script. And then another nice addition here is that that's a typical way for Python, that if you can use this script standalone as well. So you don't have to use the startup tools script, but you can load it directly into QTM as well. And then it will actually call the add menu function by itself when using this construction. It's considered as a main function. So this is a way you can use all these scripts that are actually there, can be used as standalone as well. So yeah, one more thing is this hello world is nice, but we don't do anything with the data yet, so it's not that useful. And Jeff is going to present in much more detail the resources we have on scripting there, the useful stuff. But let me first do a very simple example of how to do something here. Let me reload the script first. That is doing something with the data. So one thing we can do is, for example, we can get some information about selections. So if I select one of the markers here, so the waist back I'm selecting here, and then we have a command selection, get selections. So here we can see what we get. If we have selected anything, this will be filled with some information, and we see that there is one selection that is has a certain type. It's a trajectory, and it has the ID 1249. And yeah, part index. Just look at the documentation what that means. I don't know exactly what that is now. So the ID can be used then later to actually access the data. So it's a data series, a 3D data series, and it is this is the idea to actually retrieve the data that is associated with this trajectory. So another thing we can, for example, select is we can get the current frame position. So I move the frame somewhere, and then I use the get current frame function, a timeline function, and then showing what the current frame is. We are at frame 916. Well, here it shows we are at frame 917, but the reason is that the index is 0 based and not 1 based as it is in the timeline in QTM. So this is actually the correct index for our timeline at this current frame. Mm-hmm. So let's now do something in the script that shows something more useful. So I have a very simple thing that looks at a currently selected trajectory. It gets the data from that trajectory. It does some modifications of it, and then it places a virtual marker with these modified data from the trajectory. So first, adding the function here. Again, that is what is supposed to be executed. Then we are. Oh, that was not everything. So there we go. I just copied the last part of that function as well. There we go. So this is basically, it gets the selection. It opens the selected data. So it gets all the samples in this case, not just the current frame. Then it's modifying the data so that all the X is set to 0, the Y is set to 0, and then the Z is set to double. So it's vector 2. And I set the residual as well to 0. Then I'm going to create a new, or I'm getting the label of the currently selected trajectory. So here I'm using the trajectory ID in order to retrieve the label. And I'm appending 2Z so that it becomes a unique name. And then I'm going to add a new trajectory to QTM, and I'm going to fill that trajectory with the new data, which we just modified before. So it's a very basic function that actually does not much at all, but it's just showing that you take data, you modify data, and you then do something with the data. So the QTM command we are adding for it is the add modified trajectory, and we are associating with the function we just made here, as we did before, and we are inserting an extra menu button which allows us to do it. So there we go again. I'm reloading this script, and we look now here at the menu, and we see the new button has appeared here. I'm going to select this trajectory again, and then I'm executing this one, and we see here there's a new trajectory being displayed that is mimicking the motion of the marker we have just selected in the Z direction in this case and doubled. All right. That brings me to the end of my part here. So let's go over here to Jeff, who is going to talk more about what tools we have available for post-processing, and he is giving a little look into the kitchen here.
Thank you, Erwin. Did you want to do the poll?
Yes, that's right. I totally forgotten about the poll. Yeah, thank you for reminding me. It would be interesting to know here. I'm launching it now, so please start filling it in. We would like to know a little bit more about your background, so that Jeff knows a little bit what pitch he should take in his next presentation. So please let me know more about your experience with scripting and something about the background you have. So
yeah, and then you can go to the first slide for me.
Currently, we have a majority who have basic programming skills, so that's good. And we have most people active in life sciences, a few in engineering after that, entertainment as well. So most life sciences, most basic programming skills. So Jeff, I think that's good. We have a few experts, of course, as well, and some people with limited experience.
Okay.
So that's good. I hope everybody of you can take something of this presentation today. So Jeff, take it away.
Okay, if you can go to the next slide for me.
Sure.
For my part of the presentation, I am going to review some of the scripts that are in the tools menu or tools folder in the tools examples that are provided. The goal for these tools were not only to be somewhat practical, they are useful by themselves, but they are also really good starting examples that demonstrate various aspects of how you might approach your own scripts for QTM. At the moment, these are really about trajectory marker information and editing that data. So information about the markers, such as names in the marker sets and so on, as well as the actual data itself, doing something with the trajectory data. So for these examples, the first one I'll start off with is basically the marker set menu, which really revolves around the metadata information, the names of the markers, doing something with the names of them, looking at them and managing it in some way. So it's kind of the metadata information for the marker set. The next example that I will display will be a more advanced version of what Erwin just showed with respect to looking at some trajectory data and editing it and doing something with it that you want to do. In this case, it'll be filtering. It's a different kind of filter that we wrote as a way of showing how to edit the data. And then finally, I'll review the gap filling menus that we have. There's a couple of different techniques that we have. We thought it's useful enough to show different approaches. There's a simpler example with a short menu construction that shows how to use different QTM functions. So in this particular example, instead of modifying the data directly yourselves, you're actually leveraging the tools that already exist inside QTM to do the work for you, and by scripting, making them much more efficient. So there's the simple example, and then a less simple example, which I'll probably start with. And there's so much more that can be done that's beyond the purview of this introduction to scripting. But for advanced users, let it be known that there's a lot of different kinds of data that can be edited and created and manipulated, such as timecode information for animation customers typically. You can review timecode information, you can change it, you can fix it if it's wrong. And then something that's really powerful and something that we're expanding upon a great deal is the skeleton editing and the construction tools, so that we'll have a great deal more flexibility in using different marker sets, different marker arrangements, constructing skeletons from them directly, and so on. And then calling external applications in particular use through the REST interface. There are more advanced tools that you can use where you might use a standalone Python script to interact with QTM. And so there's a great deal of possibility there as well. Okay, so let's get to it. The example data that I'm using is from the QFL library. It's our standard skeleton solver example data set. So you can download this and follow along with what I show here. For the most part, I did add a couple pieces of data, but I don't think that'll affect the ability to follow along for the most part. So we'll start with the marker set. In all the menus, we have some help information that's available. It's just a little reminder of what that menu does and what its purpose is. It's kind of nice as a reminder. And one of the simplest tools that I like using is just a marker set summary. It takes a look at the list of markers and just tells me and gives me some information about what's going on. I have a total of 88 markers, 2 marker sets. They're all labeled. There's no unlabeled data. The marker names are good. And the animation world, the use of periods, colons, spaces, things like that are invalid characters and names of objects and scenes. So I like to have a tool that warns me ahead of time if I'm going to run into problems in that regard. And then there's some other information. I mean, you can take this and add more information that might be useful to you. So there's that. The next tool that I like using is one that's the select whole marker set. Frequently, if you're using multiple marker sets, which happens a lot in animation, it's kind of a pain to select just the markers from one marker set. You kind of have to find where the break is. But if you grab that and just say select the whole marker set, it'll find all of the ones with the same prefix. And there you go. Same way, I can just grab that one. I can say select whole marker set, and they're all selected for me. Again, it's just a little convenience tool that makes your life a little better. So I want to show the example of fixing invalid names, but this one is here. So here's a C3D file that you can just load directly into QTM, and it's a really handy way of doing it. Unfortunately, sometimes, depending on the information that's in the C3D file, the names come in with a lot of this extra prefix information. And so this particular tool is really handy for fixing the names. It just removes all the prefix information up to the colon that separated the prefix from the actual name of the marker that we were interested in. It's a great example of how you can change marker names, move things around, get things, massage the information to prepare it for whatever, maybe third-party software you might want to use the data with. So let's take a look how all of this works. The structure of our files, I find we've arrived at one that's pretty useful. I always start at the bottom of the file to look at where we have the add menu information to help remind me where I can find stuff. Visual Studio Code's a wonderful editing interface, and I highly recommend it. You can do things like I can look at it there. I can say go to the definition, and that'll show me the function that is being used by that particular menu item. And even though this file might look a little complicated, it's really straightforward. Each of these items is just one script, and then you can go to the one script function that defines it, and you have everything right there in front of you. This is a great example of the kind of interaction that you'll be doing a lot. So here you have an example of getting all of the marker IDs. It'll return everything, all the markers labeled and unlabeled. And so you have a list of those, and then you just loop through the list. You get the label. If it has a label, it's a marker with a name. If it's not a label, it's an unnamed trajectory. And so in this particular case, we're just counting all of that, the number of them, and then doing some analysis on the name, and then at the end of it, printing out the analysis. So it's a very straightforward function, and it's a great way to kind of get started on working with the data. The other one that we just did for the fixed C3D names is very similar. Again, it's just one simple function. Gets the labels for every one. It checks it, fixes the name. So this is just a little routine that changes the name and sets the label. And this could be the framework for your own maybe name conversion tool or whatever you might need in that regard. Okay. So let's move on now to actually editing some data. So we'll go into the standard Eli-ROM example. And similar to the summary information, the filter and the gap fill tools also have, little printing functions in them. And in this particular case, I'll select marker. I'll use my select whole marker set. And then under filter, I'll say print spike range is selected. So I'm curious to find out how many spikes I have in my data. And so it takes a moment because it's running through all of the markers, through all of the data, and it gives me a list of all of the spikes that were found in the data. Note that the calculation of the spikes is not exactly the same as in the trajectory editor. Unfortunately, the information in the trajectory editor is not available through scripting. So there's no way to access information like what selection region you might have in here, or what parameters you might have selected over for your fill and so on. So there's no way to access information or manipulate the trajectory editor through scripting at this time. So the spike calculations are their own, and so they usually match, but they're not exact necessarily. So for example, if we go take a look at the left wrist in right here, and we can see that the spike ranges match pretty closely. They might be different by a frame, but basically it's finding the same spikes. So we can zoom in and take a look and see what it thinks is a spike. And what does that one look like? So let's see, a good one is for, yeah, that's a good one right here. So you can get an idea of what the spike region looks like. And the way the filter that we have as an example is called a median cut filter. And what the median cut filter does is it looks at the current frame and it looks at the samples around it. It orders the samples and then takes the median value of those. Basically what it's doing is it's getting rid of outliers. So I can say median cut filter selected, and you can see how it's changed that region. It changed the part that was a spike. And we can find some other examples. There's a better example, I think, here if we go to the right wrist in. So if we look for the right wrist in, and I think this third one is a really good one. Yeah, there we go. Again, this is a pretty prominent spike. It's pretty obvious. So if I go to that frame, I can say median cut filter the selected frame, and you can see what it does. And if I undo that, and we can try seeing what the automatic tool does. So we can just say median cut filter the whole region for, for the entire all frames for the marker. But then, see, you have to undo a few times because multiple operations take place. It's a good combination is to cut median cut filter, then smooth the spikes, right? And so that gives a really nice result. So I find this as a very useful editing tool for animation data to remove spikes in the data. So let's take a look. Again, so we look at the filter, and then we can look at our menu here, and we can go to the definition. So this one's a little more complicated in that it's the functions are simple, but there's some other subroutines, subfunctions that it's calling. So this goes through, gets the markers that are selected, and then finds all the spike ranges for them, and then it does this local function. And the median cut range function, again, goes through all the frames of data. And essentially, this is the kind of outer loop for any data modification algorithm that you want. You could take this outer loop, and then all you need to do is basically replace this function with your own. In this case, what this is doing is the actual median cut result, but you could replace it with whatever analysis or modification you wanted. So it's not really useful to go through kind of what's going on here, except just to note that at the end of this, like you've seen with other examples, using a dictionary with values is the way that QTM communicates with Python. And so you'll be very familiar with this particular construction which is a sample of marker data. The sample has a position, which is just XYZ coordinates, and a residual. If you have more than one sample, it's merely an array of these. You'll be getting very familiar with this particular little dictionary construction. Okay. All right, so let's see this in action again. It's really useful. In this case, I'll just say Control A, because I know I have just one marker set, and I can say median cut filter, then smooth spikes, and then I can print spike range selected, and I get still some spikes left. And the reason for this is that some of the spikes can't be fixed by this particular filter. For example, in the left-hand extra, we have that one. There we go. That's the one I was looking for. So we have a big spike that's at the beginning of a gap. And so this is a good segue into talking about the gap filling tools. So what I'd like to do is I'd like to be able to fill in this gap. And we have a number of built-in tools in QTM that allow for this. What I want to talk about is the relational fill tool, which is a really handy one, or it's a very powerful one, I should say, because it uses other markers to fill in for the marker that is currently occluded. The sort of difficulty with using it is that it's a little bit of time consuming to set up. I mean, you have to click around, grab some nearby markers, and then you open up. Oops, I clicked the wrong one. So there you go. That's one of the issues, and it doesn't really fill it in because we didn't realize that one of the other markers has a gap in it during the same period of time, so it can't really do that. So then you have to search around for some other definition that will work for you. Well, instead, let us define some of these marker definitions ahead of time. So in the gap fill file, we have at the top of the file a whole bunch of definitions. So there's a dictionary with the marker names and then a relational fill definition for each of the marker names. And not only that, we have a couple of them. So the first one is one that's sort of reasonable. It uses the marker definitions for markers that are nearby, but the next one is a little crazier, as we note here, because markers that are near each other tend to occlude in groups. And what you want to do then is use some markers that might be a little farther away to do the reconstruction. So for example, in the right-hand extra, in this case now, instead of using nearby hand markers, I'm going to use like the elbow, arm, and chest, which is kind of crazy, but for short gaps, it actually works quite well. Because, for example, if I have this marker selected and I say gap fill using the first definition, it doesn't really work. But if I use the second definition, I get a result. And then even more conveniently, you can use the multipass. And this multipass is really nice because it will go through and run through all your definitions, actually a total of 4 times. And that way, if markers are relying on each other for their reconstruction, it builds up. And so you basically can reconstruct from the outside in. It can be very powerful and allow you to process data very quickly. One thing I want to note here is that the reconstruction for this particular marker isn't very good for this gap because, as you can see, there's a spike or a problem at the edge of the gap. And this is a pretty common thing. As markers get occluded, there tends to be a little lipping or a little shift in the data because the centroid kind of shifts as it gets occluded. And so it's pretty common to want to actually trim the gaps so that you get rid of any potential anomalies along those lines. So the gap fill menu has a trim gaps tool. So you can trim the gaps. There you go. And then we can say multipass, and then boom, you're done. And what's neat is, once again, I can select all the markers. I can do a gap fill multi-pass. And then now, if I do a print all gaps, no gaps. So it's just that easy to fill in all of the gaps for all of the markers in a marker set. Yeah, so again, this particular example is a little more complicated because the way it's organized is to allow for different options for running the different arrays in once or multiple times. So there's a hierarchy of functions that do that sort of thing, so they're all shared, and it's worthwhile taking a look at them to see how that's constructed. The other gap fill tool has it organized in a slightly different way that may be more convenient for you. And in this particular case, the way it works is there is a list of presets that are defined ahead of time. So again, for the different markers, but then you can choose different gap filling techniques. You don't have to use the relational one that I just showed. You can use the different the polynomial or kinematic methods to reconstruct them. And you can have, the way this one is constructed, up to 10 of these of your own. 4 are described for you, but then the rest of them are left empty so that you can describe them with your own particular definitions or marker names or whatever that you want to have reconstructed. As a result, the setup menu is a little more complicated because it's looking at that list to figure out how to make the menu, but it's not that much more complicated. So I won't bother reviewing it in detail, but it's another way or approach for handling how to customize your own workflow with the use of built-in QTM functions. And again, at the top of every file, we have this help section, and this help section is what gets printed out when you say help. So, yeah, so I think we have a little bit of time left for the Q&A session. That is what I had to show today. I'll stop sharing here, and we can return it to Erwin.
Thank you very much. I think people get a little bit the hang of it, the power of the things we just unleashed here. And again, the good thing, everything Jeff showed is actually available to you from the GitHub repository. So feel free to go in there, download the repository or fork it, whatever you prefer. And then you can start looking at what is in there and start developing your own scripts based on what you find there as well. So you don't have to start completely from scratch. There's already a lot of things to look at and to get inspired by. So I hope this will help you really to get started with this and in a more efficient way. Just want to shortly repeat the resources we have. So this webinar is going to make the recording is going to be made available very soon. We have a Q Academy tutorial coming up on this. Then, of course, you can always have a look at the appendix in the QTM manual. And the most important, last but not least, the GitHub page where you find all the things we actually just discussed. One more thing, when you're leaving, please fill out the survey questions at the end, which will help us to improve this kind of presentations and get some input about what we just presented as well. I'm very grateful if you could take a minute to have a look at that. And yeah, we can, in the meanwhile, go over and ask you more questions. Thank you for your attendance, of course. This is very nice to see so many of you here and take part of this. So I think Henrik can maybe come on here and highlight some questions, discuss them, see if there's any questions open still.
Yeah, I was just typing.
Yeah, if there's questions we cannot answer, we will take care of them afterwards as well. So.
Yeah, there's been a few questions. Was one about the trigger button. Yeah, so currently we can't, we don't have a callback for the trigger button, but it's a very interesting idea, I think. Definitely something to add in the future. Let's see, what else did we have? there was a question about plotting. That's also something we have talked about internally, and we don't currently have support for plotting in the plotting window, but that's also something we're planning to add. So yeah, I think there was some questions about our old Python SDK. I guess that's not relevant for this webinar.
Yeah, I mean, it's the distinction. We have our real-time SDKs, and that is something that is separate from the scripting interface. So
yeah. There was
that's
also
a different
a question about the sidebar, the project sidebar on the left, whether that's included in the selection module. Currently, that's not the case. But I'm not entirely sure what the use case for that is. So if you have a good use case for that, please let us know. So I think that mostly covers it. Oh, yeah, there's another question here. Are there any planned updates or expansions to the scripting capabilities in the near future? Yes. Not entirely sure when it will be, probably early next year perhaps, but there definitely will be expansions to this.
Yes, yeah, thank you very much. I leave the webinar open for a few more minutes so that you can still type your questions, but I will close the broadcast. Again, thank you very much for attending. This is really nice. I also want to have a word of thanks to Steph Knustrom, who has been very helpful in creating the nice backgrounds you see behind me, for example, and setting up the organization of setting up the webinars on the website and in Zoom. So big thanks to you, and hope to see you soon again. Bye.